All right, so you want to mute yourself on Discord and hop onto the Zoom.
All right.
You want to mute yourself on Discord and hop onto the Zoom. All right, we are streaming here.
Sweet. I'm currently. I'll have to go over Redline. I see your error in the burning questions channel.
Right.
Maybe
here.
Nick, you might be able to debug this one actually, but that error definitely shouldn't be happening. I'll have to go over Redline. I see your.
Yeah, we're gonna need to hang on. We got some.
Maybe I also hear your YouTube audio, Nick, through Zoom, but that error definitely shouldn't be happening. I'll have to go over Redline. I see your.
Yeah, we're gonna need to hang on. All right, cool. All right. I think we're good. Okay.
Okay. So welcome everybody to Office Hours. We got a bit of a new format going on here, but today we're going to be going over the 2 quests from week 2, day 1. So I'll actually pull up the fast Floward README here. Hopefully you can see my screen. And the first quest, actually, sorry, this is week 2, day 1 or day 2 content. So let me go to day 1 here. And there was a bit of a long README, but we went over access control, which was the first video, and that's also your first quest, which was week 2, day 1. We went over contract interfaces and pre and post conditions a little bit, not too much, but we introduced that a little bit, but that's not in either of your quests, so you don't fully have to worry about that. And then the last quest was trying to get set up with DAppStarter, and so we had a few people had a few problems with Yarn and Yarn Start, but we seem to be resolving them. And Redline, I know that you still have an error, and hopefully we'll try to address that by the end of this office hours. And then lastly, we had an awesome video by Nick that was going over the architectural overview of DAppStarter, which is also very helpful in our understanding, so that this week we can start interacting with a bunch of those features. So let's look at the first quest, which was week 2, quest 1. So it was called Access Control Party, and it says to look at the week 2 quest 1 folder. For this quest, you will be looking at 4 variables, A, B, C, and D, and 3 functions, public func, private func, and contract func. This was defined in subcontract.cdc. So you will see I've marked 4 different areas, number 1, 2, 3 in some contract, and number 4 in some script, where I want you to answer the following task. So for each variable, A, B, C, and D, tell me which areas they can be read, which is the read scope, and which areas they can be modified, which is the write scope. So for each function, public func, contract func, and private func, simply tell me where they can be called. And so I gave a little example here where, actually I'll go to the actual problem here first, because this won't make sense. But let's scroll up to the 2 files that I provided. So in the week 2 quest 1 folder, we have these 2 files, somecontract.cdc and somescript.cdc. So let's go to somecontract. So what I'm actually going to do is copy and paste this into a Flow Playground so that it's easier for us to read, since it'll have code highlighting and stuff like that. Okay, cool. So we're in our playground here, and we have some contract named somecontract. And in it has one variable, which is a test struct. And this test struct is of type somestruct, which is defined right here. So public struct, somestruct. Now, there's 4 variables defined in some struct. There's A, which has an access modifier, we call them, of public set. There's B, which has, an access modifier of pub. And this is the same thing as saying, I'll write here that this is the same thing as saying access all var B string. Access all and pub are completely interchangeable. Third, we have an access contract var C. And lastly, we have an access self var D. And this is also the same thing as saying private var D is a string. Increase the font size? Sure, yeah. Does that help at all? Thank you for that. So if that's all right, then I'll continue going here. So I just typed these all to a string. This doesn't matter for this example. All we're looking at is really the access modifiers. And you're also probably wondering, well, can we also have examples with, like, for example, if you wanted public set let D maybe? And the truth is, like, you can't have public set with let, simply because, sorry, did I leave the Zoom? It looks, no, it should be fine. You can't have public set with let simply because let has no write scope, right? Let is a constant. So we actually can't define a public set let here. What we can do is, we can have maybe public or access self or whatever it may be. But the reason I didn't include any examples with let is because it's not too exciting, because since let is a constant, it's only its read scope. So, if we had, for example, like if I was to take this and go down here where we had like access contract, this is, let is the same exact thing as C in this case, except that there's no write scope, but the read scope is exactly similar. So that was why I didn't include it in the examples, but that's just to let you know. So after that, we had 3 functions. We had public func, private func, and contract func. And we're just going to be using the 3 access modifiers for functions and using those as examples. Now, the other thing is, a couple people had questions about access account. So we didn't use access account only because in the Flow playground, you can't deploy multiple contracts to one account. But imagine a scenario where we can have multiple contracts. So maybe some contract 1, some contract 2, and some contract 3, all deployed to 0x01. Then if we had access account, which just simply looks like this, then we could access this in any of the contracts in this account. So it's a pretty simple idea, but we just couldn't use it with the playground since we can only deploy 1 contract per account. Okay, so let's actually run through our examples here. And also I initialized all the variables to just something simple. And we will also move on to area 2 and all that later. So in area 1, we have to define, all the variables that can be read, all the variables that can be modified, and all the functions we can call. And remember that when I say all the variables, I mean A, B, C, and D, and all the functions is public func, private func, and contract func. So let's look at the first one, which is public set. Public set has a write and read scope of all. So there's no really boundary there. So it is pretty obvious that, A can be read here. Similarly, B, C, and D, well, I'm not going to run through these individually, but B, C, and D all have a read scope of at least current and inner, right? Public has access all, has, all read scope. Access contract has contract read scope, and access self has current and inner read scope. So all of these apply here. And if you have any questions about that, feel free to ask in the office hours text. So all the variables that can be modified, this is all the variables that, can be we're basically asking about write scope here. So for public set var A, this can be, well, the write scope is everywhere. So of course we can modify that in the current and inner scope. For public var B, the write scope is current and inner. So that works because we are in the current and inner scope of where B is defined. And it's the exact same for C and D as well. So we can actually write and read all these variables here. So lastly, all the functions that we can call, there's 3 of them: public func, private func, and contract func. And all three of these access modifiers for functions, public, access self, and access contract, all have at least current and inner scope. So we can actually call all of them here as well. Private func and contract func. And to be a little bit more specific, public as an access modifier for a function can be called anywhere. Access self only current and inner, but this applies here. And access contract is anywhere in the contract. So knowing that, let's scroll down a little bit and let's go to area 2. So I've defined a separate resource called public resource sum resource. And in here, it has one field, public var e. We don't actually use e at all. I just use that as an example. So let's go to area 2 now. So area 2 is in a whole separate resource. Like I said, it's not actually in this struct. It's in a separate resource called sum resource. But we still have to figure out where the 4 variables A, B, C, and D can be read and modified, or read and modified, and the function. So let's get rid of our answers here and go through this as well. Okay. So all the variables that can be read, well, let's walk through them individually. So public set has a read scope of all, so we can obviously read it in here. Public var b, so public has a read scope of all, so we can read b in here. We can read b in here. And c has a read scope of contract. So because we're in the same contract, then we can also read c. Now here's where things get interesting. For access self var d, this only has a read scope of current and inner, which means it's where this is defined and then within. So because of the fact that this is defined in a whole separate, resource, we can't read from D. So we're not going to include D here. Now, all the variables that can be modified, let's go through this. So let's look at the write scope. Public set has a write scope of all. So we can, write to A. B has a write scope of current and inner. Access contract has a write scope of current and inner, and D has a write scope of current and inner. So none of those apply here, and it's just A. So all the functions we can call, this is sort of similar, where public, is accessible by all, so we can call public func. Private func is accessible only within the current and inner scope, so that won't work here. And access contract is accessible anywhere in the contract, so we can include contract func here as well. So does anyone have any questions about this? I know there's some sort of delay, but if you don't have any questions about this, then we'll move on to the area 3. All right, so given the delay, I'm just gonna move on, but again, if you have any questions, just feel free to ask in the office hours text channel.
There shouldn't be any delay, Jacob. It's all live on Zoom. Everyone is on Zoom, so.
Oh, okay, perfect.
Yeah.
Sweet. All right, sounds good. Awesome. So let's copy and paste these again. And get rid of our answers. Okay. So spoiler alert, this will look very similar to area 2. And I want to go over why that is before we, actually get into like the individual answers. So why might area 3 be, exactly equivalent to area 2? Well, it's because of the fact that any of the variables or any of the fields A, B, C, or D that have an access of like all scope, will apply here as well, because both of these are defined outside of the sum struct, which is over here. And so if variables can be read here, well, then they can obviously also be read here because, neither of them lies within the current and inner scope. Both of them are in the all scope. And so we really just have the same answers here. And this is very similar to variables that can be modified because this is in the all scope compared to A, B, C, and D. Variables that can be written here can also be written here. So this is A as well. And the functions we can call, another spoiler alert, is very similar to what we have here as well, because if we can call public function here, then we should also be able to call public function here. And if contract func is able to be called here, well, this is also pretty simple because contract func is accessible in the contract. And since we're in the same contract, we can call this. Awesome. So that goes over areas 1, 2, and 3 that are in the contract code. And then the 4th area lies in some script. So let's copy and paste this into our Flow playground. And let's just assume that here, I'll change this to 0x01, and this will, okay, good, this won't give us an error. So now we're in area 4, and let's copy and paste our answer format again to here. Okay. So let's just walk through this last example, and then we'll go over the intro to DAppStarter. So all the variables that can be read, well, this is in the all scope. And so the only variables that can be read in the all scope are A and B. Notice that we didn't include C here because C can only be read inside the contract, since it has an access contract modifier. Now, all the variables that can be modified, there's only one variable that can be modified in the all scope, and that's A, because it has public set. Lastly, all the functions we can call, the only function that has, that's accessible in the all scope is public func. And this is because contract func has an access modifier that only allows it to be accessible in the contract, and private func is only accessible in the current inner scope, and we're in the all scope right now. So this completes week 2, quest 1. And if anyone has any questions about that, please feel free to ask. And if not, we're going to move on to the second quest, which goes over how to get started with DAppStarter. Oh, I keep going to the day 2 content. Maybe show one can test to see if oh, okay, good idea. So we'll go over how we can test that right now. So let's actually deploy. We should be able to deploy this contract if there's no errors, and there's no errors here. So yeah, let's go over how we can test this. So let's go in here and try and define some, let's try and define some logs in here so we can actually see if something's being printed. Okay. So the first area was area 1, right? And so we want to prove that all these variables can be read, modified, and all the functions can be called. So let's log A as an example, self.a. Let's, log self.d as an example. And let's also try and, see which variables can be modified. So I'll put these under the read scope to test this example. And then for the modified one, let's say self.a equals 17, self.b equals 18. So we'll test, these ones. And actually, you know what I'll do? I'll include the examples for all of them just to make sure that we're writing exhaustive tests. So self.c, and then we'll also attempt to modify these ones. And I'm just putting in random numbers. And then all the functions we can call, we'll call self.public func, we'll call self.contract func, and we'll call self.private func. And in here, we're just going to log public func was called. In here, log public or private func was called. And in here, we're going to log contract func was called. Okay, cool. So now we've got our setup here. So let's deploy our contract again. And we're getting a playground bug. So I have to refresh this page. At this point, I'm sure you've seen this contract bug too many times, but we make it work. Awesome. So we have it deployed now. All right. So how are we going to test this? Well, let's go in here. So this is struct func, and we're just going to call this struct func, see if all these logs happen. And you know what? Why don't we actually log these again to make sure that they're modified? And then we'll call self.public func. So, I might have to redeploy this again because I just added those logs. Okay. So in our script, in our main script, let's just say we have to import some contract from 0x01. And let's just call some contract dot test struct dot struct func, and let's see what happens. So here we go. We logged A, B, C, and D, and then we logged the updated values 17, 18, 19, 20, and then we have these ones, which is public func was called, contract func was called, and private func was called. So you can see that this all worked. What we thought was right was actually correct because of our tests. So let's go over maybe one more example let's go over in our script, from area 4. And just for the sake of time, since the other two are going to be relatively similar, let's go over this. So let's define a new script in here. And this is going to import some contract from 0x01. And in here, we had said that the variables that can be accessed or read was A and B. Variables that can be modified was A, and functions that can be called public func. So let's try and make sure that this is true. So let's log some contract dot test struct dot A. Let's also log some contract dot test struct dot B. Let's try and modify A. So some contract dot test struct dot A equals 17. Some contract. Oh, and then we'll log A to see if it changes. So some contract dot test struct dot A, and I'll set this to Jacob's the best, and functions that can be called are public funcs. So let's say some contract dot test struct dot public func. All right, so let's see if if these get logged correctly. Let's see if our change to A takes place. And let's see if we can call public func. So let's execute, or let me clear first, and let's execute. And you'll see that we logged A and B. We also modified A to be Jacob is the best, and that's what it printed. And we also see public func was called. Now, just for one last thing, let's try and get an error. So some contract dot test struct dot contract func, and look, we have an error. Similarly, let's try and modify B or something. Some contract dot test struct dot B equals Jacob is the worst. And you'll see we get an error here because this would never make sense anyway. All right, so that goes over the access contract stuff or access modifier stuff. And if we're all good with that, thank you, BZ, for suggesting we go over some tests. That was a good idea. All right, so I'll leave this up just in case, but let's go over the next one. And hopefully, Redline, we will address your error when we go through this, but we might have to look at yours individually. Okay, so week 2, quest 2 says dappiness. For this quest, follow you getting our DappStarter DApp video. Get the fast Floward foundation on DappStarter and attempt to run your project as instructed in the video. If you can yarn start, see the UI harness, and submit all the day 1 action cards, you are done. Simply submit a screenshot of the return values of the action cards. So best of luck on your quest. You got to see you next time, Cadence Adventures. Okay. Oh, and slight thing, if you've ever watched Cowboy Bebop, this is a reference to that anime. Just an interesting fact. Okay. So let's go to DappStarter dot or I'll put up over here, DappStarter.decentology.com. Okay. And this is, as I said in the video, this is a, this is the, sorry, I'm distracted by the Discord, but this is where we're going to get our DappStarter DApp, and we're going to get the fast Floward foundation. So just like I said in the video, we're going to be using the Flow blockchain, but for future reference, there are a bunch of other blockchains here that have some other foundations. So since we're in office hours, let's try to explore a little bit. Let's go to Ethereum. So you might want to make an Ethereum dApp, and you'll see that it automatically, selects Solidity. There's 2 different frameworks you can choose from, and you'll see that, there's smart contract features like administrator role, contract access, or contract run state. You can play around with these if you want. You can also select a custom token, maybe if you want to create it on the Ethereum blockchain. And there's a bunch of other stuff you can choose, like different types of file storage, IPFS and SIA. So there truly is a lot of different things you can do with DappStarter. But for our use case, we're going to click on Flow, which will automatically select Cadence. And let's just use Vanilla.js. And let's select the fast Floward foundation. Now, if you want to, in your free time, I would also suggest running through some of these other foundations because there's some really helpful examples of how you might implement or define your own contracts. And in the next week or maybe even 2 weeks, mostly next week actually, we're going to be thinking about how we can take our own examples of what we want to build and how we're going to write those contracts ourselves. And I personally think that it never hurts to go over different examples of contracts so you can start seeing a lot of the different ways that Cadence developers implement their own ideas in the form of contracts. So for our use case, we're going to be clicking the Fast Floward Foundation, and we're going to go to dApp customization, and I'm going to put Morgan is the best, and we're going to create dApp. Now, for many of you, like I said in the video, you're going to have to log in here. But if you log in, you should just be able to, create your dApp. So here's our dApp Starter project called Morgan is the Best. And, we can view this on GitHub if we go here and we just copy the link and, go to a GitHub page. And you'll see that this is all of our code. And there's a bunch of prerequisites here. Now, I know that some of you might have maybe skipped this portion. This is definitely helpful, and your dApp won't work if you don't have these. So you must have Node.js. The biggest one I've seen is that people forgetting to have Yarn, and the Flow CLI you should all have from week 1 with Morgan. And there's a bunch of other stuff here that you can use, but these are the main prerequisites that you must have. So let's go back here and let's copy our link. And I'm going to go into my dApp Starter dApps directory, clear this, and just git clone, and then put the link to my project. So it should get cloned, and let's cd into, it's called Coherent Luffados, and we're going to clear again and click and type yarn. So in the video, this is where I was playing some Flappy Bird to try and ease the boredom. But this is definitely the longest step, and it only takes even a few minutes to install all the dependencies that we're going to need. And once that happens, we'll yarn start our project. So to make sure that there's no errors with our dApp, just a few things. I would make sure that when you're git cloning into a directory, you're not git cloning into a directory that has workspaces in its path name, because if you do that, then it's going to give you an error because we're using Yarn workspaces. You'll see here actually, there's workspace. So because we're using Yarn workspaces, you don't want workspace as a name in your path, or else it'll give you a problem. I saw that before. And another part was just making sure that there's no errors upon Yarn when you're Yarn installing. You will get a bunch of warnings, maybe some Lerna warnings, which is just code highlighting on the client side. We'll see that on Thursday, but make sure there's no crazy errors here. So once it says success, I'm going to clear this again. And for some of you, you're going to be able to put yarn start, but I'll show you that this might bring up an error. Oh no, this doesn't. So I fixed this error on my machine. But I'm actually gonna stop this and redo this for many of you that might have errors on Mac. If you see something like, a lot of the times it'll say like e-access permission denied or something like that, looks like that. What you're gonna want to do is type sudo yarn start instead, and this will get past those errors. And if it doesn't, then please ask in the Burning Questions channel. I know that BZ actually was having problems with e-access permission denied, and he fixed it by running yarn test initially. But for many of you, you might have to run a special command that's separate. And so I'll provide you with that answer if you get stuck at e-access permission denied. But let's try sudo yarn start, and let's type in our password. And this should work for most of you on Mac. And if you're not on Mac, if you're on Windows, make sure that you're running your like a terminal as an administrator. So that's the equivalent of doing sudo yarn start on Mac. And let's enlarge the screen so that the text isn't that small. Hopefully that's readable. And BZ says, Flappy was the hardest part of this tutorial. My record was like 2 at the dependent. Yeah, no, yeah, it's really funny. Yeah, I think Flappy Bird is a essential part of the yarn process. And every time that you yarn, you can try and beat your record. So that's definitely, you know, a requirement when you're yarn installing. So let's just run through the beauty of dApp Starter here. You know, so we yarn started. It created it started the Flow emulator all on its own using the service account. Then it's going to generate accounts for us. So we don't have to do all of that annoying CLI stuff where we had to do Flow accounts, create and copy and paste keys everywhere. This will do this all for us. Then it's going to start deploying our contracts to the accounts. And actually, in my video from today for week 2, day 2, you're actually going to be going over all 3 of these contracts. So Kibble, Kitty Items, and Kitty Items Market. And these are being deployed to the emulator right now, or to the account right now. And then it transpiles all of our scripts and transactions. So this is just making sure that our scripts and transactions compile. And then, you know, if it's successful, it should finish here. So compiled successfully. And it says compiled successfully. You can now view Decentology dApp Starter for your browser at localhost 5000. So, you know, we've booted up and, you know, it's going to say dappiness for you. And where you're going to want to go is the UI harness, and you're going to see Fast Floward, and it says Kitty Items for the participants of the Fast Floward Bootcamp. So this is exactly what you'll need. And then you'll click View. And so this is where our UI harness is. And this is my favorite part of dApp Starter, where, you know, it automatically sets up a UI for us so that we don't have to do that ourselves. We don't have to run transactions or scripts from the CLI. We can just do it all from these action cards themselves. And throughout this week, you know, this might be confusing at first, and you might be asking, well, Jacob, like, how the heck is this calling, you know, our scripts and transactions? And that's the entire purpose of this week. So the Fast Forward foundation that I gave you is essentially a finished dApp with a bunch of missing puzzle pieces. And throughout this week, we're going to be filling in those puzzle pieces until you understand the whole you know, like the whole process of how you're going to get action cards set up on the client, how you're going to, you know, change the dApp lib, which Nick touched on during the architectural video, and we'll go over on Wednesday, which is tomorrow, and also how to modify your contracts and scripts and transactions, which you'll be doing in the next 2 days. So for the day 1 quest, all you want to do is set up your admin account. So you're going to, or any of these accounts you can choose from. I just chose the admin. We're going to get the balance for whichever account that you just set up. So I set up the admin, and then get supply. And so if you can see these 3 things pop up, then perfect, you're done. You've completed your quest, and that is all you have to do. Don't go on to day 2. If you do, it will break. It won't work. So just, yeah, don't do that or else it won't work. But for today, for a little sneak peek, the content that I released today is the day 2 content. And if you correctly change the kibble.cdc contract, which I've defined for you in the README and also in the video, then these 2 will work. So we will be going over how to get these 2 to work tomorrow in office hours, but try your best to do that for the week 2 quests 3 and 4, which I released today. All right. So this concludes the second quest for day 1. If there's any questions, feel free to ask. Otherwise, we might want to address Redline's error that was posted in the Burning Questions channel.
Thank you, Jacob. That was amazing. So appreciate it. And let's give him the applause.
Thank you, Nick.
Action there. So.
Thank you very much. And thank you to Morgan as well for being super positive in the office hours text.
Great. Yeah, so I believe, Cindy, you had said you were having some issues with Git. Everyone is welcome to stick around if you want to see how we help with that. But also, I think this would be a good opportunity if anyone has any general questions about dApp Starter. Like as Jacob mentioned, we're going to go super deep into it. But if you have any high-level questions about our approach, you know, why we built it, any of that kind of stuff, we're happy to address that now.
Yep.
All right. Great. So, um,
So we have one thing from BZ. What would you say are the trade-offs of using DAppStarter instead of just doing more yourself? Well, I would say, and this is completely honest and from my personal experience, I think that DAppStarter is, wildly more helpful than doing it on your own, because of the fact that, if you were doing this on your own, you would have to, flow init, right? Deal with all the JSON. You would have to set up your own, UI if you wanted to on the front end, by, maybe pulling up a React to create a React app or something, which is, a hassle and that takes time. I think that, even if you wanted to use the Flow CLI, like we've seen before in the Burning Questions channel, there's just a ton of errors you can get there with maybe submitting RxJSON, and you have to, make sure you format all your things correctly in the CLI, and it gets annoying very quickly. You also have to install, like the on-flow types and the on-flow FCL, and you have to use the whole FCL library. As Morgan was showing you, it's really, really, really helpful to understand how to use the FCL and stuff like that. But, when you're using DAppStarter, you literally don't have to know anything about the FCL. And so that, it's very helpful for someone that just wants to get, tests running very quickly. The other thing about DAppStarter that we will go over on Thursday is it gives you pre-written tests already. So, if you download the Fast Floward Foundation, or if you go to the Kitty Adams Foundation or any of them, they give you a test, test already that you can run. And so I think that is all very helpful. Now, obviously to give an honest answer, it's not everything is perfect. And, as we've seen, sometimes the setup for DAppStarter is, a little confusing. Like some people are experiencing errors with Yarn and Yarn Start, but the hope is that as we continue, those will slowly go away until the experience is really perfect for the developer, so they can get any Dapp running in, under 5 minutes. Those are I would say, yeah. And you can go, Nick, too, as well.
So there's a follow-up question. Does DAppStarter give any limitations for future updates on Flow compared to if you had just set things up more from the ground up? So I'd like to address that. I think the best way to answer that question is to really look at what DAppStarter is doing. DAppStarter is not an opinionated framework. What it is developer tooling that orchestrates a lot of the tools such as Flow, etc., and automates that in order to allow you to focus on what you want to do, which is build an amazing Dapp. So that said, so let's say that there's an update to Flow. Well, you're going to update the CLI and you're going to go into your package JSON and update the version numbers, and you're done. DAppStarter is not, like I said, a framework. So it's not like React or something like that, where it is between you and everything else. It is just tooling that's there. Everything that you're seeing here in the UI harness there is to aid your development. You're not required to use anything. We're going to talk about DAppLib and blockchain JS, etc. That's all client-side stuff that's there to make your life easier. If you don't want to use it, you shouldn't. But when you're developing, for example, if you save a change you make to a contract, it's going to hot deploy that for you. It is automatically going to compile and deploy that for you. That is the value add that DAppStarter provides. It's an automation, and in making it so you can think and focus on your work and not on what is the command I need to use and how do I generate this account, etc. All the account generation, etc., is automated, as Jacob pointed out. So yeah, so really we like to think that there's no limitation as it is an assisted tool. One other thing that you will be very pleased to learn is, as Jacob pointed out, like things like Yarn and Yarn Start, that is bootstrapping the developer environment, whether it's DAppStarter or any other application. If dependencies are unable to install on your specific environment, that's a fact of life with today's computing environment, the development environment. But we don't like that. We don't like that developers have to go through that. So we are in the process of testing out, and probably by within 2 weeks from now or shorter than that, we will allow you the option to have the entire tooling, the emulator, everything is automatically done for you in cloud containers. So right now, the fastest dApp starter time that I have clocked is 1 minute and 22 seconds from the time you go to the website to you have this dApp running. We're going to cut that down to approximately 20 seconds from the time you go to the website to the time you have the application running, because all the emulator, etc., won't care about what version of the OS you have, what you have installed. You don't even need Docker installed because it's all done in the cloud. So that's coming very, very soon. And the people attending, the developers attending Fast Forward, you will be the first invitees to that beta experience. So we are really, really super excited about that.
Yep, that is awesome, and I can't wait for that. So I see there was a question in the burning questions. This isn't directly related to. Oh wait, sorry. So B said so. So what is that? I'm not sure what that means. Safu? Does you mean safe?
It's a meme.
Oh.
Oh,
Yeah, I haven't seen that before.
Funds are seifu. This is from the Binance guy.
Oh, I haven't seen that. I wish I saw that before. So I see there's also a yeah, Morgan, I see the flow dev same question. Yeah, I guess those flow devs aren't as cool as you and me. But the yeah, so log actually is available. Which, you know, when I started my cadence development, I always was so annoyed that log never worked. And then I randomly found that flag, like the verbose logging flag, and it's so nice to be able to see logs in your flow emulator. So yeah, yeah, of course, BC, and thank you, Nick, for that answer too. So if there's no more questions about this, then I could give a very short introduction to the week 2, day 2 quests that you will be working with. And it looks like Solver has a question about week 2, day 2. Solver says, is it possible to draw a diagram? I think Solver is still typing. So is it possible to draw a diagram and show the interactions going over the code? Kind of overwhelming. Yeah, so that is true. You know, when you first download your dApp project, it definitely is a little overwhelming. But I think if you watch Nick's architectural overview of dApp Starter, I think that should help a lot, because there are, you know, really helpful diagrams in there. What I can do, if it will help, is you know, maybe draw up a really simple example of how the interactions are taking place, and I'll actually do that right now. So let me make a new slide. So let's actually work through this together, and maybe this will help. So let's add I don't know, a simple shape here, and we're gonna call this let's enter this. So we're gonna call this this is like your contracts, right? So this will be the form of kibble.cdc, kitty items.cdc, and kitty items market.cdc. And these contracts lie in the /packages/dap/lib/contracts folder. So this is where these lie. And we're gonna drop three main boxes that you're gonna have to know about. So that's the contracts that are up here. And then we have the transaction, right? So the transaction is what's going to be interacting with your contracts. So let's say transactions. And for example, in your week 2, day 2 quest, you have to implement, I believe it's the deposit and withdraw functions of your Kibble Vault, and also your mint tokens function in your Minter resource, right? So the functions that are actually going to be using that Actually, let's go to our UI here. You're going to be implementing these two action cards. So mint tokens and transfer tokens. So these are two different transactions. One's called mint tokens and one's called transfer tokens. So let's use those as example here. So mint tokens.cdc and also transfer tokens.cdc. And these can be found, let's add a space here. These two transactions can be found inside /packages /daplib /interactions /transactions /kibble. So in this folder, you'll be able to see these two, right? So the transaction, as you've learned by now, this shouldn't be new, but let's insert an arrow here. My Google Slides, I've learned all my Google Slides skills from Nick himself, but let's draw an arrow here. So the transactions are going to be interacting with our contract, right? This should be old information from last week. And solver says, do these contracts get deployed on the emulator when yarn? Yeah. So when you yarn start, like I showed in the terminal, it's yarn starting all of your. It's going to start the emulator, and it's going to create test accounts for you. So if I go to the UI harness, it's creating these 5 accounts for you automatically, and then it's deploying the 3 contracts to one of these accounts, and it's deploying it to this admin account. And let me show you where that's happening. So right here, this is when we yarn start. You'll see it says starting the development server, and then kibble is getting deployed to it's getting deployed to 0x01c, etc. Then it's saying deploying kitty items to account this, and then it'll show that it's deploying kitty items. So these are getting deployed to 0x01c blah 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 upon yarn start. And in tomorrow's video, I've already recorded this video. We're going to be going over like where you can actually find this information. And let me give you like a slight sneak peek right now of where you can find this sort of information. Now, I'm pulling up the project right now, and this is going to be confusing because you haven't seen tomorrow's content yet. But where you can find this is in packages /daplib, and then you go to the source folder and click on dap config. You'll see that in this contracts object are all of your your contracts and which account it's deployed to. So in this example, you'll see that kibble, kitty items, and kitty items market are all deployed to this account. So this is happening all on yarn start. Okay. So hopefully that answers your question, solver. And let's go back to making our diagram. So transactions is calling the contracts, right? So what's actually calling our transactions? Well, let's make another box. And this is going to be our dap lib. The JSON file you showed, shouldn't it be named flow.json? No. So actually, I mean, Nick will probably be much better suited to answer this question.
Yeah.
But yeah.
I can address it. So also, basically the contracts are set up to be hot deployed. So it's they are certainly deployed when you do your yarn start. But anytime you edit a contract, there is a watcher on those contract files, and it will automatically deploy it. dap config.json is very specific to dap starter. It is used across the board in all our projects, regardless of blockchain, and it is independent from flow.json. But we've been collaborating very closely with the Flow team, and in subsequent versions of our dap starter, probably coming up in a week's time or so, we're gonna have it so that dap starter also automatically updates the Flow JSON file. The Flow JSON file is maintained and updated by the CLI, but with dap config, we wanted a model that also, for example, has wallet information, private key information, because we didn't want developers to have to think about all those things when developing, especially brand new developers. One of dap starter's fundamental philosophies is that when you want to build for blockchain, don't think and start with the wallet. That is how most people and most platforms do it. And we found that most Web2 developers, we lose them in language like private key and mnemonic passphrases and all that. So dap starter's core value proposition is first start building contracts and see the joy of having your DApp, work in your browser, etc., and then deal with all this wallet stuff, etc., at a later stage. So if Jacob, if you scroll down, you'll see that all the, like in Flow JSON, you've got like the service account and a couple of accounts, but here basically all the dynamically generated test accounts are all in here with their private keys, their weights, etc. And it is read by the UI in the action cards to help with your testing. So we automatically give each of these wallets a name and the ability for you to sign transactions with them, therefore eliminating any requirement to deal with wallets at this stage. Once you have your app working, etc., it's really easy to bolt on a third-party wallet like Blockto or whatever in here. But when you're working, we don't want you to have to mess with it. And so that's where DApp config comes into play. So hopefully that answered your question.
Yep. Yeah, and so just to clarify, like you won't ever really have to go into your flow.json file or your DApp config .json file, because it'll all happen for you, which that's what I really love about using DApp Starter.
So there's a follow-up question. Flow deploy update is executed using DApp config. So actually, we don't use flow deploy at all. We have a toolkit in here, which Jacob can probably go to. It's in it's rhythm.js right there. So rhythm.js, we are playing on the whole flow cadence audio kind of thing. But rhythm.js is a complete utility library we wrote, which does all kinds of things for you: test account generation, contract deployment, all of that lifting. And it automatically rewrites DApp config and updates it as needed. You don't have to think about it. You don't have to know about it. You don't have to do anything. Literally, as far as the contracts are concerned, you can actually show this right now. Go into a contract, Jacob, while having your terminal visible, and just make a small change, and you'll see what happens there.
Yeah, so watch this. So there's these gold stars are here, and let's add a comment here. So modifying kibble.cdc, and if we save this, you'll see that it will automatically redeploy in our terminal. See, so it's deploying Kibble to account this. Kibble is getting deployed again. It's deploying kitty items and deploying kitty items market. And so this happened without having to yarn start. It just does it automatically.
Yeah, so Rhythm uses the Flow SDK at portions and Flow FCL at portions. So where FCL is an opinionated wrapper around SDK. That's all it is. It just makes things a little easier. So sometimes we use that, but sometimes when we needed more low-level stuff, we went straight to the SDK. We are going to spin off Rhythm into its own repo and make it available separately for developers, whoever wants it, because if you don't want to use DApp Starter, but you want to use some of the tooling, Rhythm can be useful. So we might, in fact, not we might, we will be doing that. It's just a question of the priority.
Yep. All right. So sweet. So thank you for this question, Solver. And I'm just going to go back to making the diagram to hopefully help you out. So so we have our contracts, Kibble, kitty items, and kitty items market. Our transactions are calling our into our contract like we've seen before. And now we have this new thing called dapplib, which you'll see tomorrow during week 2, day 3. And this is going to be let's say this has JavaScript functions inside of it named mint tokens, let's say, and also transfer tokens. So transfer tokens, and these can be found in /source packages /daplib/source /dapplib.js. So if I go into the code here, it will be this file, and you'll see there's a bunch of JavaScript functions here. And I'm not going to go over this because there's an entire video about this tomorrow. So you'll have to wait till then. But the dapplib is JavaScript functions that will be calling into our transactions. So I'm going to add a arrow here that goes from here to here. And then the fourth part is the client. So that's what you're seeing right here, all these action cards. So this is what, this is the client or the UI harness. So let's say, the UI harness with action cards. And let's say that, what's one name? So day 2 kibble mint tokens. Let's just copy and paste this here. I'll have to make this visible. Wait. Oh, it's this one. So this will have, this sort of action card. And, this can be found in packages/client. And if I scroll through here, /source/harness/fast forward harness. So /source/harness/fast forward harness.js. And, in here, this is going to be calling our into our dapplib. So each of these, let's connect this arrow. Each of these action cards you see here are actually calling into our dapplib, which is calling into our transaction, which is reading into the contract. So this is sort of a very simple diagram of how that's happening. And I actually might even add this. I might clean this up a bit and add this to the README, which might help.
Yeah, Jacob, if you want to be very accurate, then between dapplib and transactions, you would put blockchain get or post.
Yeah, exactly. Yeah. So this is more of a dumbed down example, but Nick is right that, your dapplib isn't actually calling the CDC files directly. It's using blockchain.post and blockchain.get, which you'll see in tomorrow's video. And that's going to be calling your transaction. So I can add a little text box here that, this is happening through blockchain.post or blockchain.get. And I might reformat this and put this in the README, which might help. So solver is asking, okay, now if events are emitted in the contracts, what happens? Is it printed? Well, are you referring to events that we may have emitted last week or something? Because that you could just set up a like something in your dapplib or on your client that just loops through events that have been emitted in your contracts and prints them out to the console or something.
Yeah, I can also address that. So when we first integrated Flow into DappStarter, there wasn't a very clear story around events, and it had not been fully implemented in FCL. So it looks like it's there now. So we'll go ahead and wire those pieces up. I might even just work on that tonight and get it done. And that will also allow us to then enable the server API, which at present does nothing in Flow. It works really well in Ethereum, etc. But the idea is that when an event is triggered in a smart contract, it will essentially allow your server API to react and do something, whether that's update some database or anything Web 2.0 related. It would be able to do those things. But currently, we do not have event support wired up, but we'll make it a priority to get that done ASAP. Like I said, I'll take a stab at it tonight.
So we're about 2 minutes from office hours ending. If there's any questions, we can wrap up with those. And, I'll be in the Burning Questions channel along with Morgan and all of us at the Decentology team to help you wherever you may need. Jacob, what's your Flappy Bird all time? Well, I have
see that in action, man.
I have a competition with my dad that we always try and beat each other in Flappy Bird. I think his record is 50 and my record I think is 70 something. Wow. So yeah, I have gotten into the 70s. So beware. Oh, and by the way,
let's go. Let's see it.
No, I mean, well, the thing is that I usually do that on my I used to do it on my phone. Now on the computer, it's so much harder. Let's try it on the computer. But yeah, and also that prove it on the blockchain. Yeah. Yeah, we might have to make a flat. Maybe we'll make a Flappy Bird Foundation. Let's see if I can beat 10 here. I was being modest during yesterday's yarn. By the way, oh wow. But also all of these Flappy Bird skills have come from the yarn process. So I have to thank Yarn for helping me here. All I want to do is get to 10. Oh my, it's so much harder on the computer.
This is a bit embarrassing here, Jacob, after you said
Well,
70,
it's
and then it's like
so difficult.
by a factor of 10.
It's so much harder on the computer because for some reason the hitbox of the bird is so much bigger. On the phone, it's so much easier. But yeah, I'm doing terrible.
I feel much better now because mine's like record is probably 4 or something like that. So.
Every day during office hours, we'll have to try and beat the record. And someday I'll get to 10 on the computer. Got to yarn some more. Yeah, exactly.
All right, cool.
Yeah, exactly.
Yeah,
Yes. So true. So true, Morgan.
Cool. All right. We are noon.
Thanks, guys. Thank you very much. Exciting stuff.
Cindy, if
Thank
you
you.
want to stick around, we can help you out with your Git issue that you had reported.
Yeah, I'm also having trouble with yarn.
Okay, great. So stick around and we'll see if we can help you out.
Thank you.
Thanks, everyone.
Thank you.